Ugh. Hello?
Hello.
Goodbye.
Monday.
Monday.
Today is Monday.
It's not okay.
Okay, definite integral.
Mm.
Definite.
Yay. Yeah. Yay. Integrals.
Yes.
That's
So.
the only positive.
Antiderivative.
today.
Okay. Forming Riemann sums. For the function here, x squared minus 3 from 0 to 6, partition the interval into 6 interval from 0 to 6 into 4 subintervals. 4 subintervals. So how would I figure out my 4 subintervals? Remember the b minus a over n. b minus a over n. B minus a over n. So let's start off with that.
So 6
4 minus
0.
0.
6 over 4.
So it's going to be
1
6 minus 0 over 4, which is
1 and 2 thirds.
1.
And 2 thirds.
Are you sure?
Oh, wait. Half. 1 and a half.
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 Okay, so 1 1/2. So I'm going to rewrite it as something weird because I like fractions, because fractions are my friends, not food. So it's going to be 3 over 2, right? 3 over 2. Okay, so for this one right here, if we are partitioning this one into equal parts, big difference. We have the b minus n over, or b minus a over n. So on this one right here, are they using that? No. Let's take a look. Look at my parts here. Look at my parts. My first one, what is my delta x on my first one here?
1.
Delta x,
1.
delta x,
2.
delta x.
2.
There we go. So they're not equal parts. For the problems that we have been doing so far, when I'm dividing it into equal parts, I start with b minus a over n. But in this case right here, I'm not. So I'm given my parts already. Okay, so now it says left endpoint, each subintervals. Okay, left endpoint. So for this one right here, my left endpoint on this one right here is going to be 0, right?
Yes.
So what is my delta x here?
1.
So it's going to be 1, right?
Mm-hmm.
Times my f of x, which is f of
0.
0, plus, what's my next one going to be?
1.
1, it's 1 again, so it's going to be 1 times f of 1, plus my delta x on this one's going to be
2.
2. So it's 2 times f of
2.
plus my delta x on my last one,
That's 2.
2. So it's 2 times f of
4.
4. Very good. So I'm writing this out. Okay, this is going to be a lot similar to what we're going to do on a table. If I give you a table on this stuff, you're going to have, a lot of time in the middle of it or somewhere in between, you get like this huge chunk in between that's actually just going to be not even close. So using estimations, it's just an estimate. So it's not really exact. So go with it. All right. F of 0. Negative 3, right?
Mm-hmm.
Negative 3 times 1
Negative 3.
plus f of 1
Negative 2.
times 1
Negative 2.
plus f of 2
1 and
times
times 2.
2
2.
f of 4
13 and times 2, 26.
26. Okay, good. So now from here, we go ahead, add these together. What's that? 28, negative 5, 23?
Yeah.
So 23 units squared. Is that easy? So that's the left endpoint of each one. So now the next one is going to be one we haven't done yet. Midpoint. Midpoint.
Oh, yeah. Why are you throwing it out?
Why?
Quit hitting on her while I'm trying to teach you. Look, she had, like, you have her attention right there.
No.
You try to be Rico Suave here. Come on, it's math time. Okay?
I like how you're saying all this on the video.
You can have them later.
Okay, so, this next part right here says midpoint. How do I find the midpoint in between two ends?
Add them and then
Divide by 2.
Very good. Add them up and divide by 2. I'm going to do the same thing on each one of the intervals. So this one, my midpoint is going to be,
0.5.
so it's going to be 0 plus 1 divided by 2, which is 1/2, right? Okay. So again, times my delta x, but my midpoint is going to change my f of x. So my delta x is 1 times f of 1/2, right? Say yes.
Yes.
Okay, so same thing goes for here. This is going to be, my delta x there is still 1, isn't it? Plus 1 times f of, what's the midpoint in between 1 and 2?
1.5.
1.5 or
3 over 2.
3 over 2. Plus, what is this one? What is my delta x?
2 times 3.
Delta x. Delta x. How wide is it?
2.
2. Right? So it's 2 times my 3, right? F of 3. Plus, again right here, this is another delta x.
2
2
times 5.
times f of, what's this one going to be? F of what? 5. Very good. Give me back my attention ball.
It's lost somewhere in the deeps of, you know,
Of the...
Hello? Hello?
Hello?
We're alive. Maybe.
Bueno.
Maybe on the outside.
In the F's, in, it's, you know, like in the deeps of
No, yeah.
meaning and stuff.
Did you find it, Papa?
X is in. X is. No, it's right under your seat.
Is it mine?
Yeah, right there.
Oh, right.
There you go. Thank you. Okay, so f of 1/2. So it's 1/4 minus 3 is
Negative 2 3/4. 2 and 3/4.
negative 2 and 3/4. Can you give me that as an improper fraction, please?
3 over... No, okay, it's gonna be...
Negative
Negative 11 over 4.
Negative 11 over 4?
Yes.
Plus,
3
that's going to be, f of 3/2 is going to be
negative
9/4, right? Minus,
negative 3/4.
Over 4.
negative 3/4. Yep. All right. Plus 3, which is going to give me,
6. Times 2 is 12.
yeah. So 3 squared is 9. 6 times 2, 12. Plus 5. So it's 25 minus 3.
44. That's times 2. By the way.
Yeah. So minus 3 is 22. Times 2 is 44, right? All right, add those bad boys together. I'm gonna come up with 14 over 4. I don't know. So
Everybody lost fraction.
negative 14 over 4, negative 7 over 2, and that's gonna be plus 56. 56, 104,
110 over 4. What?
104 over 2, which is going to give me positive 97. 97 over 2. You guys agree, or you guys just conversating on whatever?
I'm checking.
No, we agree.
dude, seriously, I have like a really high fever right now. You know what? Someone should revoke my privilege of mathing because I'm making this up as I go.
Are you recording this?
Yes.
We tried,
Okay,
Foxer,
great.
don't worry.
Cool.
What's wrong?
No,
Why
12,
you-
12 plus plus
I got 105 over 2.
56
Foxer,
times 2.
105 over 2.
It's
Let's put it in the
102.
calculator.
56, 102?
Yeah, one
Okay, so it's 102. There, thank you.
Foxer, put in the calculator and it says 105.
Oh, 112.
It's
Yeah.
112. It's
112?
Yeah.
112, and so that makes this one is going to be 105
Yes.
Yeah.
105.
Okay, yeah.
over 2. Thank you.
We tried.
I know. I need you guys actually going through and actually doing these steps, not just staring. You know, this is like interactive. This is supposed to be you guys doing this. If I'm just up here preaching, you know, I don't even get a hallelujah or something going on here. You know?
Hallelujah.
Can I get a witness?
Yeah.
Amen.
Amen. Hallelujah.
Anyway.
So next one.
All right, so approximate definite integrals using Riemann sums. So approximate from 1 to 9 of that function by partitioning that into 4 subintervals of length of 2. So, are those equal size? Say yes.
Yes.
Yes, it is equal size. So it's basically I'm doing, it's going to be 9 minus,
But it says length already.
pen's running out of ink, 9 minus 1 over 4, which is 2.
So,
They're equal length. I'm trying to show you that it still works out.
what is dx?
dx is actually my delta x.
Oh, right.
Delta x is the
Yeah,
thickness
I know.
of that. Does that make sense?
Yeah.
Okay. So we're doing this, and now we're using left hand, okay, as a left endpoint of this intervals from 1 to 9. So what I'm going to do here is I'm going to start off by writing out all my intervals, what they're supposed to be. This is actually going to make this a whole lot easier for you. So if I start this off, so I know I'm starting at 1. Okay, what's the end of that one? 3. Next one's going to be 3 to 5, right?
And 5
5
to 7.
to 7. And 7 to 9. So that's going to help me out. The reason why I say write this out, because you want to know what your left endpoints are. You want to know what your right endpoints are. And then you could use those, each one, to actually figure out your midpoint. Because you're only going to do each piece individually. So let's start off with the left. With the left, what is my delta x? 2. All of these have the same length, don't they? They all have the same delta x, right?
Yeah.
Say yes. So I'm going to take my delta x out front. So I'm going to factor that out front. So it's going to be a 2 times, now for the left endpoint, it's going to be f of 1.
It's going to be
F of 1 is going to be,
4.
what is it?
4.
4. Very good. So I plug it in. Plus, next one's going to be 3. 0. Plus, next one's 5.
4.
So that's going to give me 4, right? Plus 7, which is 16.
16. So it's going to be 48.
So right here, I could add these together, and then I could multiply by my delta x, which is 2, because that's the same thickness for each one of those. So together, I get 24 times 2 is 48. You guys agree?
Yeah.
Okay. Now, let's do the right one. So I'm going to erase this one. You guys ready? Erase? Okay. All right.
It's called Riemann Sums.
Yeah. Riemann sums. All right. So right. So it's the same thing. Oh, I shouldn't have done that. 1, 3, 3, 5, 5, 7, 7, 9. Okay. So now we're doing the right hand side. So my first one's going to be still, again, my delta x, which is going to be 2. So it's 2, bracket. Now, of the right-hand side, so it's f of 3, which is 0, plus f of 5, which is, plus f of 7, which is, plus f of 9, which is 36. So I add those together and I come up with, let me see, that's going to be 56 times 2, which is 112. Wow, that's a big difference in between left hand and right hand, isn't it? Okay. So, given that much information, my first one was what type of estimation? That one should be an under, right? And the right hand should be an over, isn't it? Okay. So, midpoint. Okay, theoretically, my midpoint, what would my midpoint give me now?
Actually, it's gonna be like the sum of the two under and over divided by 2.
It should be, right? It should be something like that. Should be somewhere in between there. And is that closer to my actual value?
Yes.
Say yeah. Yeah, it's going to be closer to the actual value. Okay, so let's go ahead and do this. So for this one right here, it's going to be this plus this divided by 2, which is f of 2. So my delta x is still 2, right? My delta x is 2, so now it's going to be f of 2 for my first interval, which gives me 1 plus 4, which is 1, right? Plus 6, 9, 25? Yes? All right, so from there I should get, let me see, 35, 36. 36 times 2? 72 units squared? Okay, so since I know you guys wrote down all those, right? Okay, closer to the actual answer. Let's see. So I'm going to do the math to actually tell you what the exact answer is going to be. So for this, my exact answer of my integral, so hold on, let me see. Let me expand this because brain's not working yet. All right, so times 3. 241 minus 81. Minus 9. That's 1/3. Minus 3 plus 9. So given that, 6. 5 2/3 minus 5 2/3. 7. 75 2/3. Something like that.
It's a physics.
75 2/3. Now, in your handy dandy calculator, you could actually do the same thing. X squared minus 6x plus 9. I'm going to show you guys. Go right over here. This one right here next to the book. One. It's a x squared
No,
minus 6x plus 9 and dx. Ah, dang it, I was off by 1. So your calculator actually does do this.
okay, so how we do that calculation?
I just did it. But we're doing it as estimations right now. We're not actually getting into it yet, but I was actually trying to explain to you how close are we. So the right hand was a way over estimation. The left hand was what, 48 units? Okay, so that's way under, and my midpoint came out to be what? What is it? 72. So it's close to the actual, right? Because the midpoint's going to give me a little bit of over and a little bit of under. All right? So that's where I'm going to leave you guys with this. And I want you guys to work on some of your work today. Don't forget. Yeah, we actually are not getting into this one yet. We're still doing estimations. We're still doing estimations of this. Okay? All right. Like, share, and subscribe.